हम बिटकॉइन देखते हो इंजीनियरिंग क्या होते हैं? चलो क्या मैं करता हूँ सर, भाड़ में बैठ गया। गुड मॉर्निंग, नमस्कार. This is Suraj Singh speaking from Bharat, India on this day, June 8th, 2021, Tuesday. And talk is Civil Field Engineering, COVID-19 Engineers Role, Designs, Construction, Methods, Contracts, Organization, Communication, Coordination, Quality, AnnexSL, why behind quality of concrete, standard materials, talks. This talk is every day delivered at personal level to my friends around world. Every day life moves in one direction or other. Purpose is where do we stand in quality and where we do not stand in quality. That's main focus of purpose. Certificates of whatever type indicate that we have certain responsibility, we have certain duty. That's true. And to what extent we recognize quality, to what extent we recognize quality to be built into products and systems is a big question. Just saying it contains quality or its quality product is not enough. Saying is one thing, saying is one part, and doing is another part. Quality has immense definition. This definition cannot be, you can say, confined to certain limits. Yes, confinement can be done for purpose of marketing, for purpose of fixing price. That is different. But overall, if you see, there is no limit to quality for whatever project, for whatever product. Quality criteria is something else. As I usually refer to this document, quality required everywhere. Quality required everywhere, and engineering, it's a must. Is it? Can we jump out of quality and then rely upon product? That is a question mark. Can we jump out of quality and rely on product? Who shall tell us it is right or it's not right? Well, I'm sure no one would tell us. People can tell us only or tell others only when they have extensive experience on quality. There are some people who are very good in quality, but they are not, everywhere. Some people don't even understand meaning of quality. They are limited to only some part of quality and they rely upon that. But what about, is it a must? In engineering, if it is not done, if it's not complied with, if there is no quality, there is no future. We have to keep in mind, if there is no quality, either on product or on system or in whatever consideration, there is no future for product, there is no future for system, and there is no future for use. Engineers and engineering are different world. There are so many classes of engineers, so many specialists of engineers, I think, many branches of engineering, many specializations. All are engineers. Every country has engineers. And without engineers, nothing can move. That's also true. Nothing can move. If engineers cannot deliver quality, I can say there is something wrong, because engineer means quality, engineers means quantity, engineer means design, engineer means delivery. Engineer is not a title here, it's a profession, it's a commitment. Engineer means do it. Basics of engineer is think, do, or plan it, do it, check it, review it, improve it. If you plan, you do it. And if you do it, you check it. And if you check it, you review it, amend it, correct it. That is very basic of engineering. These four words tell something about ourselves, something about society, something about industrialization, something about production, something about design, something about work done on sites, in factories. All are covered within this range. And in organizational management, it's also accepted. In quality system structure, this is also accepted widely, that you have to plan. If there is some project, you have to plan. After planning, you have to do it. And after doing, or while doing, you have to check it. And of course, when you check, means there will be something right and there will be something not right. What is not right, you have to correct it and you have to improve it. That is system, that is requirement. Engineers have to realize this fact, and they realize it. And particularly civil engineers have to change quality aspect, or else quality cannot exist. Now, civil engineering field is having various dimensions. I am sure there is no corner left, there is no square left in engineering civil which does not cover all aspects of life. All aspects of life. It doesn't cover. Civil engineering means real physical development. That is civil engineering. It is engineering at start. It is engineering at square one, or origin. If you can take graphics on x-axis and y-axis, you will find origin, and that origin says civil engineer resides there. Civil engineer resides at origin. He looks into negative of graphics, negative areas, also looks into positive areas, and that engineer tries to pull negative effects into positive life. Never tries to put positive life into negative effects. That is basics of engineering. Means whatever doesn't exist, whatever is not done, engineer tries to do it. And that is beauty of civil engineering, which I can say is an only engineering where sacrifice is required. Sacrifice of comfort, sacrifice of living conditions, sacrifice of, not sitting in comfortable rooms and no timings. Engineer civil is someone like that. Commonly speaking, civil engineers a real home is sky. Real home is open areas. Real civil engineer. Room that civil engineer gets while working. You cannot say those are rooms. Those are just chambers where engineer sits and works. Doesn't care for dressing sense. Doesn't care for something else. If some facility is given, that's fine. That's for work. And that's what I say. My talk is not for civil engineer upliftment, but because they work in such conditions, and that's generally all time, particularly on projects for years together, they work in those conditions. Therefore, it impacts on their health, it impacts on their conduct, it also impacts on their personality. A fake word that's called diplomacy is never a friend to civil engineer. If civil engineer believes in diplomacy, that shall be very difficult to work in those harsh conditions where you have to deal with generally workers and to some extent public, and also to your staff and to, you can say, other educated community, whosoever. Civil engineer can change and has to change desert into city, has to, you can say, sometimes reclaim lands, like, can refill some portion, some beach of sea or river, and can convert that reclaimed area into some facilities plant by doing massive activity of reclamation, site preparation, and then construction. Design is a responsibility of civil engineer. Basically, once civil engineer clears all these activities of designs, particularly for works, for projects, for facilities, then other engineers come into play. Machine, electrical, electronics, and whatever else, those all engineers come into play. Again I say, engineers must realize this fact, and in particular, civil engineers have to change quality aspect, or else quality cannot exist. Since civil engineer has to start in beginning itself, even at survey point. This means start of quality starts, you can say, at threshold of that point, civil engineer. So if civil engineer, they did it. There are so many engineers on historical record. They devoted their lives towards product and quality. But I don't understand, or I can't find, I'm sorry to say, regretfully, saying that I'm unable to find quality in this era. When 2021 is running, if you go back to 20 years, and I don't know what shall happen in coming 20 years, I was not able to find what is imagined, what is, I can say, dream about quality. You see, you can go and see structures being constructed all over. You go and see, particularly in our country. Go to private structures, go to government structures. It may be whatever sort of structures. I don't know what shall be your comments if you see, maybe if you little know about quality. You will feel very angry sometime. I feel so. Angry in a sense means, if I am civil engineer, I can't digest bad quality. Though I can't do anything, I have no right there, no power there. And sometimes I even if I ask someone this is what you are doing, means they don't care. They don't care. Means even you tell someone it should be done this way, and nobody bothers. And same applies to people also. People of this country who spend their investment, savings on their projects, their houses or buildings or whatever you say. After all, they are consumers, they are buyers. They don't care. They are interested in money spending, but they may say, oh, I want quality work. But you want quality work. Do you understand quality? Points that. If you don't understand quality, there's no way out. There's no way out. Systems quality to be achieved, that is one part. Individual quality to be amended and one must be forced, that's another part. Element or product quality to be achieved, that is another part. Individual attitude quality to be learned, that's also another part. And dedication to be applied, that is also one more part. Commitment to be fulfilled, that is last part. And other parameters to deal with per requirements. I think these are not all, but some. That we establish some system ourselves in whatever organization we have work. If I have my own organization, I have to establish my system. For example, suppose I have consultancy or I have a contracting company or whatever I do, I have to establish my system, and that system should meet organizational requirements that are detailed out on certain system organization standards. We have to comply that in our system. That is the minimum requirement. And it's happening. It has been happening. That is for organization, means system. System has to be followed and complied with. It's not question of just getting certification. Just people think I have certification. Certification, okay, fine, you have certification. It doesn't mean this fulfills everything. Certification is paper. It doesn't mean it speaks. Yes, I think all organizations, all companies have got third-party certificates. They usually call them ISO 9000 or something else. That's okay, that's a certification. But is that certification converted to real certification or real work? Points that. Is that certification meant only for wall posting, wall decoration? Or you are complying in letter and spirit to an extent work is possible? My question is that. You will find systems defined everywhere. Books are there for systems. All major companies will show you systems, so in soft copy as well as in hard copy. You will be happy to read that. Oh, what a thought this company is having. They say, yes, that is true. They have systems quality to be achieved, individual quality to be amended, and one must be forced. Now this is a point where we have to concentrate. Individual quality to be amended and one must be forced. Individual quality applies to all personal as well as owner and client. Individuals are involved everywhere. It's that company, organization, owner is individual or a group of individuals. Employees are individuals. Workers are individuals. In consultancy, all consultants are individuals. Or even in, you can say, public, all are individuals. Now, individuals actually make system. It's not system that automatically is created or is established. It's an individual quality that actually leads to quality system. But what is thought is different. Now, individual quality cannot be uniform, cannot be on same pattern. It has to be brought to that pattern. It has to be brought to that pattern. But it can be brought only when it is known what is to be brought at uniform pattern. System should speak that, and individuals should receive that. Individual who is trained in university or institution, and individuals who have not been trained but trained on work fronts. At least from those who have been trained from academical institutes, it is expected that they understand this. For those who work in field, we depend on them, but they must be taught, they must be, told, and they must be forced to follow some requirement. Those who are educated one, they also ignore. This is true. Means it is a contemplation now. It's contemplation now. What quality? Quality, they sometimes take it for granted to some extent. I can say not 100%, but to some extent when they find, oh, this is problematic, this costs a lot, this is not viable, we have to think for our honor. When question comes, we have to think for honor, there is a question mark, big question mark. You are more interested in thinking for honor, not for work, not for end user. Here point lapses. Okay, honor pays you, that is true. Honor pays you for work. Honor doesn't say you just give me profit. Honor also expects that you have to give good work, good public. Good public, you have to earn public reputation. But everything stops at that point when cost is considered. People want to save as much as possible and also want simultaneously to be on, you can say, claimable quality status. That's where I differ. See, work is work. You have to produce work according to system. It is true. Indeed, it is true. You have to do that. And you do that. But profit is already there, calculated. No project tender is offered without including element of profit. Because it is business, it is commerce, commercial point. But if there is working error, there is calculation error, you may say, we are losing. You are losing, so you want to save that from compromise on quality. But you forget at that time that quality compromising will not make any saving, rather it will make losses. Because sometime in future your bad work will be known to everyone because of defects or because of something else, and at that time corrective cost shall be very high, or you may have to do rework. When you have to do rework at later stage, when follow-up activities like sequential activities have been carried out, those activities shall also be impacted upon. So every individual has to be taught like that. Taught means training, have to be trained like that. Maybe engineers they are, maybe foremen they are, or maybe supervisors they are, maybe consultants they are, whoever they are. Wherever individuals are required, it is engaged, they should understand this point. Long-term loss is more expensive than short-term corrective loss. That's what we call plan, do, check and review or act. You plan in time, you do in time, you check in time. I think system will move, there's no problem, but they should be clearly done. These activities should be clearly done. When you plan something, you have to plan keeping in mind whole work, a whole project. So I can say individual quality to be amended at one must be forced. What is quality then in individual? This is quality of engineer, quality of individual that you should know, and you know what is work. First of all, you are qualified. I would not say you have to know that you are qualified. You are qualified. You are educated. You are responsible. You are committed. You have to be committed. But what is commitment? What is point in commitment? What is commitment? Is to deliver project on a scheduled date, you call it commitment, or to comply with all requirements is commitment, and deliver in time is commitment. These 2 points you have to decide. Or you think just deliver at on day of completion without worrying about something else is commitment. But you forget that there are other restraints also. Consulting group, other groups, third party group. You are lucky, you may say, if these are with you or they stand with you. But I would say even if they stand with you, you are not lucky. Because nobody stands with you except you stand with you. You get my point? Third party, consultant, engineer. Okay, you have good relations with them. You establish good relations. And they support you on project in their own interest, not in your interest. Because if there's an error, there's a mistake, and there is a question mark, then they will try to put all blames on you, because you are responsible contractor, responsible contracting engineer. Try to understand where I am directing to. I am directing to those people who are responsible for work, for execution. First responsibility goes to them because they are paid for that work. They are deliverer of that work. They are people who will pay you. They are people who do job and be paid. So first responsibility comes to them. So if contracting staff, contracting engineer becomes strict, I think quality can be achieved, but it doesn't happen. It never happens. I'm talking for all companies, not only companies but also for individual people. There's no variance in quality. I've not seen any specific achievements in quality for major projects even. You have seen bridges have collapsed, you have seen buildings have collapsed, and you have seen generally higher news that this accident happened there or happened there. Why did it happen? Because there is something wrong somewhere. It's wrong in construction, it's wrong in design, it's wrong in somewhere else, supervision or safety somewhere. Wherever it is, it's all part of quality, and somewhere quality is missed. It may be working quality, it may be design quality, it may be construction quality, it may be lapses on safety, organization, it may be lapses somewhere else. So ultimately, quality leads to accidents also. Quality leads to, you can say, no payment also. It is a group work. It's not individual work. Individual leads. And if leader doesn't care, followers won't care. Leadership is a part here. I'm not talking of leadership, but it comes automatically into picture when we talk of work. Leadership is very important in construction, because without leadership, follow-up cannot be done, and without follow-up, works cannot be done. If you leave work to people only, you shall never do it. A concentrated effort is that you should have a good leader, a leader who understands project, who understands what scope project has, who understands what future this project has, whether or not this can be completed according to contract data, and if this cannot be completed in contract data time, then what should be done to recover that time which you have lost, or what is another way out. If individual can be reached to that level, forget it is contract engineer or it is client engineer. Individuals are individuals. You have some role to play, but when quality criteria is considered, that role applies uniformly to everyone. If contractor is interested in quality, there is no way quality cannot be achieved. If engineer is interested in quality, there is no way quality cannot be achieved. And if owner on top of all is interested to get quality, I think that is end of everything. It's owner ultimately who is liable financially and for every risk. It is owner, or you may say employer on contract. It is money of people through employer that goes to project. It's money of none else. Ultimately, it is either your own money, if it's your own structure, or it's money of public. If it's public structure, it may come through whatever source, it doesn't matter. But it comes to project and it procures resources, all resources. So here individual quality requires to be amended, and that quality is that you have to be decisive, leader has to be decisive, leader on behalf of contractor, leader on behalf of consultant, leader on behalf of employer, leader on behalf of third party. All must have commitment to quality, and they understand quality as well. They must understand. It's not formality they have to do. They have to do all acts that can give input to quality, and it requires major understanding. It not only understanding but also work. If you plan something, you plan it properly. If you do it properly. Why there should be mistake? When you're checking, you're planning, you're doing, there should be no mistake. If there is no mistake, then there's no question that product quality is not achieved. In theory it's okay, in talk it's okay, but in works it fails. It fails. Individual attitude quality to be learned. And that's what I'm talking about. Individual attitude. It is our attitude we talk of. Individual attitude. Now I'm talking of amending individual. Individual also must have a will to apply amendment. Must have a will to learn more and more. It's not that what I have to do with this. I am given this task, I am doing this. That's understanding is created. I think you cannot give quality. You have to give quality to higher than what's required. Then you can say we have done it because it would compensate for some losses. But that doesn't happen. Construction engineering is very wide field. In construction engineering, every item is voluminous, is of, you can say, higher quantity. From excavation to final finishes, it applies uniformly. It's not concrete alone. It's not concrete alone, or steel alone, or structural steel alone that we talk of. I'm talking of all items, and not only execution items, also design items. Problem comes in when we are not able to communicate properly. Communication doesn't mean design communication. It doesn't mean communication through specifications only or through contract documents, contract form only. Communication means it is also verbal communication, it's written communication, it is signal communication. And in fact, it is, you can say, communication, whatever it is done, required maybe interaction with people by those who work with them or who lead them. Interaction is very important. Everybody cannot read documents, but everybody can understand. That understanding is important. A person explains to them, how one person can explain, that's also important. How those people who are there, they receive, that's also important. So we have to be clear about this attitude of people. If people are open to understand, open to get knowledge, open to get information, and people who are ready to take out some of their valuable time to teach them, that's very good homework for for quality induction. Quality doesn't mean quality control, again I say, that's only a part of that. But an attitude should be developed that I have to think quality first. Quality first, just like we say safety first. There's a parallel. Safety first, that is a requirement for health, for safety, for environment. But here, quality, which is above safety, because safety is a support there for work to achieve. But here, quality is number one, because if quality fails, all fail, everything fails. Individual must have thorough understanding about what does quality mean, why this lesson cannot be taught to individual, and create dedication and devotion within that individual. When individual understands what is required by organization, it's not only profit or loss or project, but also reputation of organization. Organization should be known that it gives quality. That is rarely done. It doesn't matter which company you are, which organization you are, international organization or national organization. I think it doesn't matter. Not at all. It doesn't matter. What matters is achieve. What did you achieve? What did you achieve in your works? I have seen very small vendors also sometimes give excellent quality. And I have seen top class international people or national level companies, they don't even bother about quality. Forget quality, they don't bother about how to organize some work, how to organize distribution of activities. I have seen such people also. I don't want to name here. They exist everywhere. It may be government project, it may be private project, it may be PPE. I feel sometimes really, or I have not seen very bad quality in my career due to I was not engaged in this country for decades, possibly. That is my weakness, that I did not enjoy work here. But work is work. If I work in Abu Dhabi or in Baghdad, or I work elsewhere, it doesn't mean what you work there you can't work here. These are same engineers and working class people who work overseas in Gulf and Middle East. And I think Gulf and Middle East are considered quality nations as far as construction is concerned. There was a time when Iraq, Baghdad was very strong in quality. I have that experience, I have that background of, I worked there for some time and I could understand. I could know meaning of quality there. I could know meaning, although in those times there was no systems organizations, but they did not depend on systems. Those nations did not depend on systems. They depended on will to achieve quality, because quality was important for them. Durability was important for them. because they spend their money, they spend everything. They were to develop their nation. And when you have to think like that, we have to develop project, we have to develop society status. Naturally, quality would come in. We are not, we are having our own nationals here to work as engineers. If our nationals cannot think that, I don't expect that from foreigners. You may be having many leaders in your company from overseas, but people here belonging to this country must think of what they have to do. But it doesn't happen. It doesn't happen. I think people have been impatient. While quality requires patience, quality requires concentration. That is very big issue I am talking. We are unable to upgrade status of our workers, status of our professionals. I have many opportunities to talk to our experienced engineers, civil. Many times I see their postings, I see their writings, I see their mindset, and when you interact with someone, you will find a varying difference among understanding of system and quality. Some people only think if you control testing, if you give test results, that is quality. If somebody thinks if you test a cube of concrete and that is passed, it's quality. That's what I say. Understanding of quality system is more important. These are only representative tests. These are not total tests. Total test lies in your mind. You know what you did on that project. Where is error? Nobody else can know except you. And you hide that. You did not recognize that self and you have to take action self. That honesty doesn't exist. And remember, engineering means honesty. Engineering means sincerity. Because if honesty, sincerity, dedication, everything is missing, you cannot do engineering, at least civil engineering, construction engineering. Our design engineers do a lot. This is appreciable. World over they do. They do a lot of research in designs, in design activities. They refer to codes, they refer to systems, everything. And they go too minutely into designs, which is also appreciable. I like it. Means at least you work on papers, you use softwares, you get benefit of that. But when it goes to work, it goes to site. Every content of design, which designer expected or must expect, that this shall be converted to physical work, physical item, physical project. It should be done. But it doesn't happen because everybody thinks of its way. Contractor is paid. Contractor wants to make money, but it's not contractor owner who is responsible. It is engineer who is in charge of that project. What way that engineer thinks, what way that engineer has a plan in mind. I am sure even if you spoil quality, you cannot make profit more than what was done. If people think, I don't understand thinking, what thinking it is, that some say if quality is bad means contractor made profit. I don't know this point, how it is. If contractor made additional profit because of quality, well, I think this is not logical. It doesn't make any sense. Because material is to be included on project, temporary works and preparatory works have to be included on project, staff is to be included. There is nothing that is not included. You can save. It's only supervision. It's only your what you had to do, or you could not control that. You can say failure of control. What was expected to be done, It could be due to ignorance, or it could be due to, you know, not adhering to requirements, or you can say carelessness. I think carelessness is more important here, because assuming they will do themselves. Yes, that's point. Assuming they would themselves. I see many works here and there, even in a smart city like Faridabad. Concrete goes on, works go on. No one responsible is seen on these projects at time of important activity. At least activity which once done cannot be verified later on, like concrete activity, structural concrete. Once you lay it, pour it, and it is done, I think there is no way you can verify what happened to that, how was it done, except to refer to your cube reports, which would never come failure. It's also true. It should be, but it would never come failed. I was saying, this is beauty of our nation. In formality we are good. We shall do all formality, and then see, show documents. And if documents speak right, it's okay. You are right. So this is what I say, parameters to deal with per requirements. So what it means, systems quality to be achieved, that can happen only if we think of quality. And if we didn't think of quality and work, system cannot work. System works because individuals work, and individuals work because they are committed to what they, so we will deliver it, committed to deliveries, quality delivery. And these individuals' quality to be amended every day, every time. They keep amending, they keep remembering all time. They are there to deliver quantity with quality, not quantity alone. Even there is force from honor. Yes, sometimes you can say these professionals are, because the employees, they are bound by employer's force. There can be some instances as such. I'm not giving exemption to engineers here, but because everybody is not courageous, they have to survive also in job, and that I think is more important for them, because employment is employment. So they can come under impression of force and ignore something. That's possibility, but this is uniform possibility here. I think this is only possibility. They bow down, and that leads to loss of quality concentration. Commitment cannot be delivered, commitment cannot be fulfilled if we have this. It cannot be fulfilled. That's the important point. So what I said, individual attitude quality to be learned, dedication to be applied, commitment to be fulfilled, other parameters to deal with per requirements. Now, designs of structures and other must be qualitative and reliable. Nobody can deny this fact, and there is no structural engineer, I think, or design engineer who would not think to give quality design. I think every design engineer has a will to deliver design in a best possible manner. That is true. They want to give a design that there should be left nothing undone. That's also true. They are interested to deliver a reliable design, a quality design. But it can happen only when you understand quality system and quality. When you design, you imagine everything is ideal. I also design, and I can say yes. I assume only that every activity shall be based on ideal assumption. Or they will do best concrete, don't worry. They will do best layout, they will buy best material. You have that positive picture in your mind. You're optimistic all time. that I assume that, and then you put a disclaimer on your design that it happens beyond my control, just like everybody does. Supervision or control or something else is not within our control. These are beyond our control. So if these design conditions, design criteria is violated, then we will not be responsible or accountable. This is either disclaimed or it is understood. But this doesn't mean anything. You see, why shall your design not be implemented? I don't think site guys don't want to implement it. I don't think that. Yes, there may be technical problems, construction problems, which do happen, or design may not be comfortably done. Always design should be simple, even if complication calculations based. You have done too much work on calculations, but design drawing should be very simple. You understand and know it that those who work on sites, workforce or engineers, they may not be that level expert as designer is. That's also true. As far as designs, drawings and specifications are concerned, designers are supposed to be expert. Otherwise, they cannot decide, they cannot make engineering judgment and move further. But you have to keep in mind caliber of that person who works on site. That person, maybe you assume, is very much professional, but in fact no. It's not only here, this applies to all over the world. Rarely you'll find those people to mark. Maybe they're a little higher than our people, but designer has to keep in mind, first of all, communication of design. Your design should communicate what is required. It's not simply design you are given and said okay. Design drawing should be clear, and they should tell everyone it's not difficult in construction. What usually we say, buildability of design, constructability of design should be very much clear, explicit. Looking at drawing, that design engineer's work must be appreciated, and if it goes to ease of construction, and that designer is real designer, I would say, experienced prototype designer knows site problems, and if that design creates issues on site, execution issues, which I cannot change because of these issues, that's called less constructible design, which is not welcomed by those people. So many issues are there, and all these count as quality. Reliable means if I don't like design, I don't like the drawing, I feel something, because you cannot call for every question, every difficulty. It's until there's technical problem or there's a coordination problem, we do not call designers for clarification, because we assume whatever is designed is perfect. That point is kept in mind. But ultimately, if it affects our performance, then it's question, big question. Well, so what I say, all stage designs being significant, but merely design does not suffice if construction and development are not affected to specified marks. Design drawings must have quality input and duly coordinated details, keeping abreast site working conditions. For site cannot be relied upon, give clear notes, specify properly and explicitly. construction based on reasonable coordinated quality designs. That's also important. Construction based on reasonable coordinated quality designs. All activities must be taken care of, but it doesn't happen. Reason being lethargy in attitude and undue strains in minds. Why should site work suffer? Because of deficiencies in designs. Design accountability must be fixed if accountability on constructed product or element is required. Design and construction qualities are complementary to each other. I repeat, all activities must be taken care of, but it doesn't happen. Reason, lethargy in attitude, and undue strains in minds. Why should site work suffer? Because of deficiencies in designs. Design accountability must be fixed if accountability on constructed product or element is required. Design and construction qualities are complementary to each other. Ultimately, why I explain all? It's only for solution. What solution? How to do this? You know, what I understand, we are lacking somewhere significantly, and that is unknown to us as professionals. I'm not saying unknown to as professionals, but here in ours we are not complying with that. We stick only to some specifications, which are government specifications rather. We don't devise anything ourselves. You know, when we work on sites, what is most important is there are many activities, hundreds of activities. How these activities should be conducted, should be performed. That sequence in every activity is different because of activity nature. And every person has different understanding of activity. Every engineer has different approach. Every supervisor has another different approach. It happens. Telling of mind doesn't happen. Even two engineers sit together, they will talk in different tone for same thing. This happens that there are many persons on site, many ways, many thinking. Site is not for person, site is for work. Our purpose is, our objective is quality work. Quality work is our objective. So what is solution? Means drawings and specification, do they give solution? Yes, they must, because drawings contain complete details and specifications tell us what we have to do. But do you think everybody knows it? There are hundreds of people on sites. There may be many engineers on site. There are many foremen and supervisors on site. There will be consultants, third party. And do you think they all go through those detailed texts of specification? I don't accept it. Generally, duty of going through specification is taken care of by project engineers or site engineers. Even designers lack it. Okay, design is different part. Once it is been specified, the specifier has done its job. Site specification understanding job is to be held by project leaders. Everybody cannot go through specifications, that is not possible. every foreman, every supervisor, every charge hand, every general foreman, or even junior engineers, or you know fresh engineers, you can say, budding engineers, you can say, they don't even know what they have to do. So responsibility goes to leading people, leading personnel, key personnel. And are they interested in that, or they only touch or refer these provisions of specifications when required? If that is the case, that's very dangerous one. That is dangerous attitude, that when you require something, you read only at that time. Because specifications affect planning. Specifications may be wrong, may be right, may be clashing, or we have to comply with them. Sometimes specifications itself say it's not clear. There are many ways it's not clear. There are many, you can say, sometimes there is no sense but document exists. So what should be done in that case? We have to, for every activity, write something or decide something in very explicit and clear way what we have to do. We means not contractor alone, it is engineer also, it is, you can say, third party as well. At least engineer and contractor, you can say, if not somebody else, at least they should agree together for each activity how it shall be carried out on site, and it should be in exactly, in accurately, you can say, in documentary form. It's not simply we have talked together, and you can say we talk together and so we agree. No, it should be in writing, and it should be quite in advance in writing, because others may refer to this before doing job. If they cannot understand that document, it can be translated to their language, but that may be inconvenient. So before doing job, or much in advance, site person is responsible, is duty bound to explain to its juniors what they have to do about this activity, how they have to execute this. Everything should be stated, explained to them, and if they be given copy of this document, which I call it method statement, and it's known worldwide as method statement or procedure, and that procedure is actually, you can say, derived specification from existing specifications. Means volumes of specifications cannot be referred for every activity, so that real extracts, applicable extracts, are put on that small statement, which we call method statement. Maybe every activity has certain pages of that statement, which should give a scope of that activity, and what about documents of that activity, drawings or specification references, and also, you can say, safety issues concerned on that activity, and what materials we are going to use, approval materials and others, and possibly quantity of that activity if possible, not necessary, and then what is quality criteria of that can be embedded in various stages of that statement, in procedure form, method form, what is procedure and which equipment do we need, and what are documents that are readily available with this statement. That's all required, means half information. Main is procedure. Documents people know, they would, drawings they have, okay, they may not go to specifications, but now they know what they have to do. As much as explained is better. Means you have to give some, if required, some plan also, how this work shall be done, which machine is required, how many people are required. It just generally, I'm telling you, it applies to all items in one way or other. So those people who are leaders of that activity crew, It may be major or small, major or minor activity. They people understand. They understand, and it is clear to everybody. It's approved by contracting company and also by engineers or owner, you can say. It will be better, much better, if that is complied with, because it's your own statement, your own agreement for that activity. And if you do that, well, I think I can say that because every criteria has been considered in this, and this is quality work. So I have to say that method statement is a support, is a medium to connect to quality production. And that method statement, once is ready, it can be applied to similar activities by some amendments, by some addition, and that is also very good. I think not only good but only reliable way. That point where thus I say expression of details in convenient format for work, performance, and define elaborate performance, or else no work can be carried out in sequence and output suffers. With bad standards of working, method statements must be made necessary for activities implementation, or else diverse ways can be used without achieving any level of uniformity. It all links to time, cost, and risks. If you follow method statement in time, it's ready in time, it's been done on actual requirement of work, I think you will be able to be within time limits, cost limits, and risks, because when you devise this technical statement, it will import everything, and you will know that this is within the limit or not, because if resources you put in on that, this is enough. Without these resources you can't do anything. So that's real budget, because even if there's low budget, you have to spend money on that. Maybe your low pricing is responsible for this. I can't answer that, but this is also fact that this is a requirement. You have used all those requirements to optimum way. In optimum way means, you can say, without this what cannot be done. That is, borderline. You cannot withdraw from this any element. Even if you withdraw 2 persons from their crew, work cannot be done. It may be delayed by half a day. That point is also lost. So we have to understand this. Time, cost, and risks are covered in that. And of course, when work is quality work, risk-free work, quality work, and safe work, controlled work. So of course there is reliability. Nobody can say no. It is there. Safety, serviceability, durability, and other applicable knowledge areas, they all fall within that. That is reliability. And of course analysis, you can say. Analysis must have been done before writing a statement. It is done everywhere. It's not only in construction. Analysis is done in all fields of life. Analysis is in social field, economic field, or political field, health field, engineering field. I can say there is no field that exists without certain analysis. Without analysis, actually, we cannot understand anything. That's also true. And if we conduct analysis, we find solutions, we find problems and their solutions. Analysis will tell you problem as well, remember. It's not simply solution. Because even if you take some word, article meaning of some word, you try to understand the article meaning, you'll find meaning of that word is hidden in that word itself. It happens. That's also a kind of analysis. But we are talking of engineering analysis. We are talking of applicable life analysis. And that analysis in engineering exists in abundance. Not only in abundance, in every step, to some extent you have to analyze, and in some step you have to do only analysis. So analysis actually provides you with solution, not only one solution, many solutions, because you have to do many analysis for some item. So many analysis means many problems knowing and many solutions extraction. And those solutions when combined together, they give proper answer. So analysis is such a tool. Maybe you do not name it, but you do it. Every engineer does it. Every businessman does it. Or you can say every expert does it. Some are mathematical based analysis and some are non-mathematical based analysis. Some are contemplatory analysis, some are thought based analysis. It depends on individuals only. So in an exclusive engineering basis, analysis is an exclusive engineering basis and intellect tool that can penetrate into all problems and unearth required solutions, and there exists no way from where or through which analysis approaches could be avoided. It's a must all problems to be understood by this approach. Then synthesis, an analytical engineering approach. An analytical based engineering result to apply an analytical based performance gives a chain of solutions that can be named synthesis, and that analysis and synthesis both are complementary to each other. It's kind of network, and that is based on unit of thinking which applies everywhere and everywhere. If it's not applied, then it is neither called analysis nor it's called synthesis. Synthesis should fit in analysis. Analysis should check out, bring solutions, and that is synthesis unit. You get my point. Analysis plus analysis plus analysis equal to synthesis plus synthesis plus synthesis. But sequence of synthesis should fit into questions of analysis. And for all those, it is analysis, it is synthesis, and it is thinking that are linked in train. And thinking is engine, and others are, you know what I mean. Only way is thinking. Sometimes thinking is so complicated, it's so powerful, it moves from some requirement, but it brings back with powerful requirements, powerful solutions. That way to understand. And when I say, when many solutions are available, we can formulate them, we can give them form, or we can say we can give them templates, that this can be used for future also. And a combination of templates, we can say. It's called vision. What we view, this is our projection, and that is form. And formats having many information in same form, varied information in same form, which is called contemplation, templation. And it goes to application, without which application won't be qualitative, won't be reliable, and that's called engineering. Application must be affected, and that is engineering, and that is main point. I think we have to understand that. Without that, nothing is going to happen. That's also main point of view, we can say. So non-conformance product is called substandard, and therefore That's not accepted, rejected, that is. Non-conformance means engineers is either careless or ignorant or incompetent one and therefore redundant personnel. We must change to requirements to achieve intended quality standards for universal recognition, quality requirements checks being a must, missing which we have to blame ourselves for quality failure. Engineering means quality application and continuous improvement of quality CIQ. No way to not to comply with defined or specified quality levels because definition of quality is a must and that definition requires to be achieved or else work leads to status of being unsuccessful and to be reformed. just answer, that's all. Documents are giving this some my contention. You answered this. Really unfortunate. It was unfortunate. What is unfortunate? Nothing is unfortunate. Okay, don't close. What is unfortunate in this? You know, the facts not the facts. Quality requirement and checks that we are more interested in to know is quality requirements and checks, which are very informative point. You have to think from every point of view. You can say these points are really very important from generality as well as specific issues. These points are not very ordinary. In fact, these points are not very ordinary points, are clear points actually. I'm trying to find some book page that I want to show to you, and that's where it is. Floppy CG, health insurance, HPI, these chapters that I'm going to share with you, and I have shared already many, are actually very important one. There's one I'm looking for, that is firing range, that I want to share with you. That is, I'm just trying to find where it is. Firing range. It's very important one. Barjan firing range, Qatar. I want to share with you, and that's why I'm little uneasy now. I got it, and I'm going to share with you. I'm just taking print out of that. So I think you got it now. Firing range. और कुछ भी कर सकते हैं, किसी फॉर्मेट, and that is in कर सकते हैं, करिए आपकी मर्जी है. So you can see this document. It is very clear here. What it says here, this is next picture. What is this document? And this is close. It was this. Come on, go. Before going further, I would like to show this document. This is from Google actually. This was taken from Google, and this is firing range, shooting range here. You can say shooting range. This is main building of shooting range, and there is this building and this building. This is pistol range, whereas this is firing range building. These are actually and this is shooting range, a kind of open. This is covered, and this is baffle wall. These two are baffle walls, 300 meters long. You can just blow up this one. Okay, you can see this is a baffle wall here, and you can say this is target pit here. Target pit RCC structure, not clearly visible, but it is there. I'll show you that one. And this is here are this is 1, 2 and 3. 1, 1, 2 and 3. These are underground passages, and others are gantries, and then there are target pits as well. This is a bullet trap chamber, bullet trap chamber, and there is no roof here. It's all open. They're all open, and you can say these are RCC walls here, and these are armored plates on gantry protection for bullets, and this RCC structure here, and there are so many points in that's firing range. Of course, I can see. I'm just showing this because I have to explain to you now. This is quality requirement checks, guides for certain items, and in this items I have taken in are checklist and ITPs inspection and test plans for indicative purpose only. Indicative guidance, and that is checklist is common for all. All items are there. About you can say about only 48 items, not many. There will be many more in future when we continue on this. I'm taking only this. These items are, we have talked about setting out and excavations, hand excavations. When I speak this means checklist already spoken. Then formation, blinding, concrete protection or waterproofing, foundation footings, preparatory works, stub columns, preparatory works, backfill works, grade slab, RCC columns works, RCC check, and that is checklist for RCC lift well. I think the list is repeated here. I'll correct that. RCC walls, RCC longitudinal staircase, RCC suspended slab, RCC pedestal footings, RCC footings, blocks for structural steel, and where gantries have to be inserted in or put in. Then RCC works for DC generator and alternator foundation works, and of course RCC fairface structural works, architectural finish works, RCC hoddy blocks, RCC sloping portion floor slab, RCC general sloping portion suspended slab, RCC heavy compressor foundation tabletop, RCC tabletop columns works, RCC tabletop works, below ground RCC swimming pools, firing or shooting range works, foundation footing, concrete pour. Now these were only preparatory works items. You can say up to 27. In this case only I am talking of firing or shooting range. This is the last one which I have shown you. I will give you glimpses of this as well. This actual project. This is actual project, and you can see how long it is, and you can see there's a pole here, all lines, and it's connected like this. Goes here. This is a sports hall complex here, a sports hall complex, and it goes like that. You can see, if you just squeeze it down, blow it down, you'll find this better. The problem is this portion is not visible, and there are other bodies here. This is I will not actually tell more than that, except this I've taken it from Google down, and if I go to more the next text, What I explained is also important in this. That is here. After this, I try to explain about concrete pour on these. That is step column concrete pour. After that is step column concrete pour. Then grade slab concrete pour, columns concrete pour, walls concrete pour, lift well walls concrete pour, and then longitudinal stair concrete pour, suspended slab concrete pour, pedestal footings concrete pour, footing blocks, then DC generator and alternator concrete pour, fair face concrete, architectural finish works, holy slab concrete pour, sloping portion floor concrete pour, sloping portion suspended slab concrete pour, heavy compressor foundation concrete pour, RCC tabletop, columns concrete pour, RCC tabletop slab concrete pour, below ground RCC swimming pool concrete pour, firing or shooting range concrete pour, and also maybe I add more depending on what comes to my mind. These are actually measures that usually happen on structures like buildings or plants or heavy works. And I think for understanding of total engineering in structures and buildings, I'm not talking of all structures, I'm talking of buildings only, or heavy foundations. There are hundreds of structures more which I do not know. I'm not that much knowledgeable person. I have a limited knowledge, and whatever knowledge I do have, I refer to that only. So these are, you can say, 48 points, out of which you can say others are, you can say, only for purpose of I think here concrete pour starts here, at 28th. At 28th concrete pour starts, and up to 27 there are checklists for preparatory works and preparatory works, whereas others are concrete pours. Up to 27 I have, up to 26th I have talked. I was talking on 26th item. I had to talk of firing range shooting, which I was doing now. That's one I'm doing now. Swimming pool, I'll try to show you this. Means I'll explain to you this in other pages which I have put in, and I shall also put this on SAFE. This is sketches. So I just try to show you what is firing range about. And swimming pools, now I'm going to, I'm going to talk about this quality requirements. So let's go to swimming pool first of all. That I did not complete yet. I say I complete, but it's not complete. Sometimes we have to do a number of times what we do. Oh my God, we will reach by an error, I think. Tabletop column works. Tabletops. Is that, I think, balanced environment. That is this. Quality requirement checkpoints. Yes, it is that. Checklist for below ground. Checklist for below ground RCC swimming pool. That I explained to you this a lot, but still, because it is water retaining structure, it is very important. It is very it is very much attention attraction is there, should be there, and if we don't do that, we do injustice to ourselves. I had some points written in this long back. I don't know whether I should read that. The light is not that much here. I think I may not be able to read that probably, but let me try best. This is swimming pool, swimming pool, you can say, as I said before, its internal size is given here 25 by 13, that is pool size, pool shelf size. And let me open it some, I can find some sketch on this. It should be somewhere here. It's not here actually. So I'll go to that required page to get you that one in here. It's very important from explanation point of view. Explanation point of view is different. That is here, I think. Swimming pool. Can be here. Yes, that's this one. Not this one, I will not show this one. 2. Okay, 3, 4, 5. Yes, it's that. I'm going to the main picture I'm trying to show you in this case. That's main one. This is isometric of swimming pool, and this was drawn on in 89, 19, no, I think, yes, possibly, I don't exactly remember when it was drawn. Well, that's not important. I explained to you before also, I'm talking of swimming pool. You can imagine that we have to produce this on site within ground itself. What you have to produce? You have to produce this shelf, this shelf, and a shelf, you can say, you call it pool shelf. What? Swimming pool shelf. What is shelf in your homes? It's a kind of shelf where swimming can be done. It's a kind of circulatory reservoir. It's not reservoir alone. And there's a balance tank here. Means if there's a shortage, deficiency of swimming water, swimming cannot be done immediately without fail. This tank, which is called balance tank, supplies required water there to replenish loss due to circulation overflow. And when you jump down for swimming from this ladder and platform, this is diving platform or diving board, we call it, diving, D-I-V-I-N-G. You dive down, you enter, you dive down to this deep end here, where water is more, and you will not hit, if you dive here, you will hit this RCC. Here it's more than 2.5 or around 2.5 meter. You will not hit RCC slab or floor, and you swim, go to this portion, shallow, and come out. That is the whole idea behind this. How you shall swim, that's not in scope of this talk. In this talk we have components of the swimming pool that's going to be worked upon, that's going to be delivered as part of this component of this pool. So swimming pool is not alone RCC structure, but having all services within itself, water services, then electrical services. In this pool there is no mechanical services except in services. Building of this, there's a pumping and filtration and chlorination. You can say pumping, filtration, chlorination, acid controls, etc. or dryness services are done. It's very simple actually, not very complicated, but these services are embedded in concrete, and therefore these are complicated situation. This is complicated situation. Services cannot be used as industries. These services cannot be on surface. These are services inbuilt in concrete. You know all that. Still I am just telling for reference. For example, this pipe you can see is going to pump house, is written for purpose of water goes, and there's a ring main around like this. It goes back, comes here. That's called ring main for balance tank. And then also enters here. This line comes from there, and this is from filtration. Is written from filter. It goes, filter water comes, maybe chlorinated filter water. Sir, treated water comes here. It goes into line, and then it goes like this for circulation. And this is real water. This water you use for swimming, and when you use for swimming, you jump into that. During swimming itself, there is surface outflow, and that outflow takes effect here and here on these three sides. There are open drains covered with plastic grills like this. Open drain, this is open drain, this is floor, this is open drain. When you jump, this is water side. You jump into this, water comes onto this overflow water or surge water, and this is plastic grating. This water goes into this drain, this small drain, then drained out to header pipe here down, and from there it goes around. It goes to filtration for recirculation. Filtration and chlorination then comes back again to this line. And how many times it can be used, that depends on design. I'm not going to comment on that. My purpose is engineering, and this time allows that. So whatever water comes in here down, it goes here on all these lines. And there are certain types of drains that are available here. You can see that this is one type, this is another type, and this is third type. One is ordinary drain, that's full one. I think if you can see, let me see it this way if you can. Okay, I am making a small one. This is draining out. Here is corner drain, corner of drain, and this is you can say this is full drain, and one is joined with this. This is just for information, it is. So what I say now, you got my purpose. What I am to say, this is purpose of pool, that water after use goes down into drain and recirculated. And this is RCC chamber, RCC reservoir with inlet and outlet functions. Water supplies there and water supplies here also. And when there's deficiency, immediately water is taken from this, and there's a vent here formed. So this supplies these metal covers for maintenance purpose. And that's one part. And electrical services are here. Electrical services are here, which keeps at night this water illuminated. And my point of view is construction of this, and this is, you can say, electrical waterproof electrical services bulb provided here. And this is section of this RCC, because how PVC conduit runs here and connects to this light. Everything is waterproof here. Water supply pipes, of course, electrical supply, and there's no other supply, and that's because it's open air tank. Yes, it's not situated on ground, it's situated on within earth, within ground. It's not above ground. And here, that soil pressure is to be registered by this structure, upward pressure from below, and side pressures from all sides. These walls. Of course, this is 1 meter deep, so pressure of soil is lesser this side. In shallow end, pressure is not that much, but in this end and balance tank area, there's enough pressure. 2.5 meter deep or more, so it is enough pressure. You can say, if you consider 2 point something tons per cubic meter of soil, and it's 2.5 WH cube, or WH square over 2, you can say WH square over 2, so 2 into 2.6, 2.25 means 12.5 over you can say WH 6.25 2.12, so this is 12.5 WH square over 2, H is 2.5, 6.25 into 12 point something over 2, 6, around 6 tons. I can say H is also W, okay, 6 tons pressure, which is quite. Moment is then another point of particularly for this portion. WH cube over 6, 2 into 2.5 into 2.5 into 2.5 over 6. And you can calculate that one. I'm not going to calculate that one. If I calculate it, take time. We have to, means design is of course not very complicated. It's not very difficult, design of this structure, because vertical weight is not very much here. You see here also it's just about 1 meter deep, and might as well at stake 1.25 tons per square meter vertical pressure. It's not, and here also it's 2.5 to 3 tons per square meter. So keeping safe bearing capacity, I think this may not be very much. So same for balance tank. Design criteria is not very difficult. Only point is because of what stresses are reduced, and that way you can say it's important to design properly, because concrete and steel cannot be allowed same stress as in dry structures. This wet structure, and they have to keep in mind also future of structure. So that is design consideration only, but my point of view is how to construct it qualitatively. That's very important. That's the purpose of this. I have gone through all activities, shown to you what's written on swimming pool. That is a written format, but we have to understand other way also. This is not standard, dimensions are standard one, and this is not only design of swimming pool. There can be varied designs. There can be circular swimming pools, there can be elliptical swimming pools, or there can be different designs of swimming pools, but basics is that function is this. I have seen people talking about swimming pools without any deep end or shallow end, or without any balance tank. If you raise them questions, they won't answer. This happens. Okay, this was contemplated in, you can say, when I said I dealt with this in 1987, means much before then. But in 80s, you can say in 80s this was criteria. So now it depends upon in which area you are working, you are installing this tank. Where I installed, that was not, not clay soil, but it was not clay soil, it's ordinary soil, you can say like limestone. It was limestone. It's not big problematic for stability of this, but question was how to carry it out. That was important. For quality purpose, you should know what you are going to do. You won't get this type of sketch everywhere, because it takes time. Maybe sometimes you get due to software availability, you can do that. But you have to think your way, means everything is not possible from sketches. You have to contemplate in your mind, if you're a site person, what I'm going to do. This is I have to produce for this small project, that is only swimming pool for 25 by 13 internal size, and that's actually internal size 25 by 13. That is the size, you can say, not balance tanks, but this size of pool. Then balance tank is separate item, integrated the same. So we have how much cubic meter concrete starts, very important, because always basis level is not less than 30 centimeter, 300. Walls are never less than 200 or more, maybe 300, depending on, because water stress 300 can be. Whatever design requires, you have to ensure it's right. And then usual activities, of course, you know where site is, where location is, that you have to follow it. And what about excavation, what we have to follow? There may be possibilities that water table is higher, not very low. In that case, you have to deal with water dewateration also. Dewatering activity I have to deal with. If that is the case, I'm not saying yes. Generally, it may not happen. But if it happens, means you have to take care of that also. and because not clay soil, so you have to put you installation of submerged pump in excavation trench itself for that purpose. So in this main activity you have to do from design point of view, from working design point of view, from you can say shop drawing point of view. Though it's not shop drawing, it's just working drawing. You have architectural, structural services drawings with you, and you should know how these services shall impact with each other. Maybe they clash with each other, or what's best way. In that case you have to make drawings like this. Then you have to, after this you have to make its services drawings and its tiling drawings, other drawings depending on requirement, because people should directly do work on site if they have complete information. I can't expect people on site to waste time on this. It's project engineer responsible for all this. Project engineer or project leader or manager, organizer, what to say. That should have concept on this once it's decided. In this case, there is no complication because water services are independent of electrical services. There's distant away, and there's no other services in this case. But how to do it? It's best way is first how to understand it. And once you understand it clearly, then doing is not a big problem. So in this case, design activity is construction drawings like this, and those drawings which are schematic given by contract, the contract document, those must be converted to working drawings. Working drawings are all disciplines here and should be on site available after approval. Without approval, can't do anything. So in this case, you can say setting out is an important criteria. Not only the setting out, the surrounding status, setting out changing room, filter service plant, or whatever is a pergola. These are in the normal facilities. Maybe you have to put in changing rooms, some toilets as well. That's requirement. Now in this case, after setting out, everything is done. You have to excavate to this profile. Excavation markings are there. Marking is there. That's important one. We have to take that into consideration and do further. The marking is really appreciable. Once you mark, keeping around, I think 2 meters area for circulation purpose, that I have given in text also. I'm just telling you what to do in brief how to handle this, because without complete vision it's not easy to be done. It's not easy. I wanted to show you more sketches of this, I think. Yes, I think this is also better if I show you this. That was isometric, and this is a little different because this is shelf here, and this is balance tank, you can see. And here you can see this is deep end, these drains are there supplying water. I think this is discharge, deep end. Yes, these are discharge. This is discharge out. Yes, this is discharge, this is inflow, this is discharge, and this is water floodlights, this balance tank, and this is you can say in deep end there's discharge, so discharge is not a problem because of pressure, and pump you have to use for supplying water. And here is pergola. You may see this is pergola like structure. You can see this pergola. I'll just a little more. This pergola, and this is here is pump room. You can see pump room here, and these are changing rooms. And here is also, you can see some rooms here also provided, and also this is, I think, chlorination tank, and this are filter tank, maybe filter tank, I can't see it exactly. And this is discharge manhole. This is shade, this pergola, like the structures in this. So you can very well understand that for 5 minutes. Read that, gain more knowledge. So I think you have taken few minutes and you now clear about this. What I want to say, we are interested in RCC quality of this structure. We are interested in quality about how these services can be inserted. That is water supply services, electrical services, drainage services, and also water treatment like chlorination and filtration, and acid chambers, and also to make sure that circulation remains intact, temperatures of water remain within limits, and it's not covered pool, but if it's required it can be covered. That's not a big deal. That's not considered in this because this swimming pool was for army, it was for defense personnel, and they enjoy such way. But if it's residential one, in that case it can be covered by structures by whatever way. By it can be indoor, means it can be indoor framed structure. In so many villas you will find that, in so many bungalows you will find covered swimming pools in main hall, and also many more services are provided there. HVAC services, dehumidification, etc. all are taken care of. But here it's very ordinary swimming pool for strong people, and there is an poolside carpet also for comforts, pergola for relaxing, and only that purpose. But my issue is related to activities that we take care of. So we know only certain activities are involved in this: excavation activity and structural activity. Excavation activity, which requires absolute excavation, real excavation, not undue excavation. Excavation in trimming form, in a form that profile is created in designed way. It's two-level excavation with one slope. That excavation is very important because extra excavation is not permitted and is not preferred also. We cannot close our eyes. We have to keep in control all time until this excavation for 2 or 3 days or 1 day, depending on nature of soil, and disposal of excavated material, because we have to shift that material also immediately. Can't pull up there. Stockpiles can't be kept there. That's the purpose. And excavation safety, circulation of truck and excavator, and safety of people and circulation around, all must be kept in mind while doing that. Safety says whatever excavator works there, shovel or truck works there, they all must follow safety arrangements. You know very well, we have talked safety many times, and I'll talk in future also. But once you reach excavation, finally you reach dressing. You have to do dressing. You also to apply, if some treatment is designed for you, it's mandated to treat that soil first. Or if there is weak soil below that requires to improve that portion of soil foundation, you have to do that as well. Soil improvement, if it's required. I'm not saying maybe it's required, then you have to do that. It all includes before concrete work starts, before formation work starts. It may be compaction if some backfill is done, though it's not permitted. Compaction and backfill are not permitted if some extra excavation is done. And that's only purpose of blinding. Actually, when we say blinding means first leveling concrete, you can say. We call in our country, people call it lean concrete. Well, I would say it's just formation level concrete. Where is there undue levels, those are filled up. No backfill is permitted. If there is some loose soil, that has to come out. No way you can keep in. And if somebody says, oh no, backfill it, now that's not specifically right, because maybe there is 5 centimeter more, 10 centimeter more, not 6 feet more, means in range of 300 mm, 200 mm, 150 mm, varying from 50 mm to say 200 mm. You cannot backfill that. There may be some average of, let us say, 50 mm or 100 mm around. That must be taken care of by blinding concrete. No other way. Blinding concrete is cover up of all those unevenness, and that's why we do it, to make surface workable for further activities. And that's called blinding concrete, which varies between 50 mm to say 100 mm, depending on requirement. So that's the sole purpose of this. In this case, we have 2 different levels of blinding and 1 slope. So we have to do in that case comfortably, safely, Blinding should be done after approval of surface preparation. Once it is approved by person who is responsible, means our quality requirement engineer as well as authorized engineer or contract engineer. That must be done. Ground must be inspected properly. Every loose metal should be out. Water, let me try and can say. We are ready, we become ready for pour of blinding. And pour of blinding is that you have to order for concrete, or if you have to mix on site, because it's blinding can be mixed on site also, not big deal. It's M20 or M25 or M15 range, M20, 25 generally. And we 50 mm, you have to fix your profile level in 3 stages, deep end, slope and shallow end. You should be well prepared. You have to fix profile for concrete top, and then quantity won't be much because it is say 30 by 25, it is 30 by 15, it is 450 square meter, let us say 450 square meter into, let us say 0.1 on average, that is 450 square meter into 0.1 meter on an average, so 45, so every 40 to 50 cubic meter you have to lay on whole area. So it can be taken from batching plant also. There is no bar. You can take from whichever source. I think batching plant is better because they will do quickly and it's over area. It won't take much time. So you can plan for batching plant concrete RMC. You can say you can start bottom deep end first, then you can go for slope gradually, and then you can go for top. It's your plan. Or you can say blinding should be done in one go. There is no other way, and it should be properly floated, made by wood using wooden floats, and it should be ready in such a way that it can allow concrete protection layer or waterproof membrane onto this. And that 3 days curing is a requirement. Layout is there on blinding, you can put layout, and it's not big layout in this, only you have to mark dimensions, but be sure of surface. If surface is bad, it needs some treatment, you have to provide some chemical application, so that the roughness of surface is removed. Because rough surfaces cause problem for your waterproof membrane. Then your blinding has gone. Blinding has covered all your area, including balance tank. It's covered all area, including balance tank. And waterproofing has to be applied all over this area. And then you have done waterproofing on blinding, with of course overlaps that has to go onto wall outside of balance tank and outside of lengthwise and widthwise walls. It may be hot torch application or it may be cold application. Generally cold application is meant for plenary this refinery facilities projects. These are, and when you say that it is torch applied, means where there is no chance of explosion, we can say, because there is chance of explosion in air due to certain motion of gaseous, but in this case when it's not that sort of area, cold application can also work. And once you have done waterproofing on this, now it depends upon what sort of waterproofing you are doing. If it's self-protected dense membrane, which are available nowadays in many classes, if those are there is no need of applying any protection mortar on that. And if no, it is you use that type, we have to protect it from impact of reinforcement placement or something else, then a mortar application, mortar layer has to be laid on that blinding for protection, and only then you can say we can start work of steel fixing and formwork, walls around pool, base slab in first stage, then we have to take up walls in second stage, and base and this balance tank slab in third stage. So to start with first stage, we have to completely install or place our reinforcing bars in position. Wherever it's come, maybe we have to wait for few minutes before doing that, or next day you can do that, it doesn't matter. You have to mark the start. You have done it by fabrication, maybe we finish back, so you can bring fabricated bars from your area of fabrication, or if they're available in the stores, your fabrication, you done your own fabrication, that's also not bad. You can provide all those bars according to requirement, in this case including starter bars of walls and balance tank. That is minimum requirement. And before that, doing that, you have to provide inserts of services, water services, electrical services, drainage services here. You have to provide these pipings before your steel is completed. And this steel is completed, you can say your services are completed. Inspections can be done for services, and rebars both must be approved. And you have to, that's very small activity we have to do for purpose of pouring base slab, and that is called base slab pour. Which activity is left now is formwork, though it's not very big quantity. Maybe you say your slab is 20 or 30 maximum, say 25, 250 mm or 300 mm thick, and you need about 400 mm or 50 and 400 farm works around this swimming pool, which cover technical. Let's see. That's point where you have to be very specific. Once steel is ready, and you can say steel is ready in this portion, all portion, and outside you have put formwork, vertical formwork, say 500 mm or 400 mm depending on support valve. There's no other way. And then you have to put kicker also, kicker form in for water bar, and water bar fabrication is required in parallel to profile. Means your water bar should move like this in between these walls, and but here fused by fusion, and where joints are coming, maybe 2 joints here, 2 joints here, 2 joints here, like that. You have to put vertical fabrication also with those ring, all 6 points be 6, and these 6 water bars be fabricated, be welded, fusion welded. So this means there about one is that welding, one part is this this ring welding. There are 6 points that are your vertical welding. So 7 fusion weldings are required to be done. These are fixed, they are inserted in this portion, whole portion, and anchored by some clamps or by some other means. The water bars remains in center of all center falls. And you should have confidence in that. Modi should have. That's the important point. Means you have done 3 items. You have done fabrication and placing of steel with complete package, and you have done within location of the services, and you have done steel fixing, you have done form work. So your activities are over. Your water bar is fixed correctly, half within proposed concrete and half outside of that. It is well secured to timber by smooth, and all parts of water bar should be in center. You have to get this point and understand this. It's a very important one. Once this is done, you can say that you are ready for pour of base slab. Important point, base slab. This is base slab, and you can plan to pour it in 3 stages. Base deep, base slab at deep end, base slab at slope end, and base slab at shallow end with kicker starter. All steel must be in position, all formwork must be in position, well anchored or fixed without any problem, without any, there should be no chance that it should move out of position, and your water bar should be is very in position. It should not be disturbed and should straight, remain straight as far as possible, because you may find some twist also in it because of the bad anchorage. So various clamps have to be placed on whole perimeter of shelf as well as balance tank wall. This must be tied up by some arrangement of tie wire or something. You can devise, as all bars should be straight, and those vertical bars can be left at this time projecting out of concrete area, which can be raised up later on. So you have to concrete quantity, which is 25 by 30, let's say 25 by 13, which is 325 something, and let's say 1/4 of that, 70 cubic meter or whatever. You have to pour some. This is also good concrete. You have to demand for pump or whatever it is. You have to see when people walk on this below ground, and they should have all the range of safety around, because this is underground tank. People may not fall. You have to do all barricading, safety warning signs, and way to go in. Also way to go. Must have ladders and ways go, and then how best transits can go in and how best they can come out. All this must be applied for. So you have fixed marks of concrete in this base slab, top slab and middle slab. You can then ask for concrete and start getting concrete after approval is done for steel for formwork and you are ready for concrete. Concrete grade, it should be 40 grade or 35 grade, or which plasticizers has to be added or not added. It's your concrete specification. And slump is not very much in this case because this is slab concrete, is a kind of, you can say, you can ask for reduced slump in this case. Is slump enough just for pumping purpose? So maybe it's 100 mm depending on site and specifications. Then you can say once you do concrete, it will take many hours, maybe 3-4 hours for this big work, and then one work for your normal rest. You have done concrete, you have to finish it. You have to make sure that water supply inserts are not broken, drainage inserts are not broken, and whatever electric conduit is coming or not coming. Then you have to give it wooden finish, and you have to roughen portion of kicker in which half water bar is in and half is out. And then you can say all extra concrete is removed and put it site scope site, doing site roughing of your kicker. Curing has to be taken care of. Where curing compound is suitable immediately, you can sprinkle for immediate purpose, immediate prevention of cracking. That's, you can say, base slab performance, base slab casting. Meanwhile, you must have parallel arrangement of fabrication of upper steel, of walls and balance tank, and also parallel arrangement for fabrication of walls also, because there are 3 and 3 joints on this. So once you have a chance to start your formwork and steel reinforcement, you have to make sure that first safety arrangements are required. Safety arrangements, working platforms and raising to work. It's very easy to fix temporary scaffolding around, inside or outside both. Now you bring your you can bring your steel fabricated materials out of yard and fix here from inside or outside by raising your scaffolding platforms well secured for people to stand. Generally from ground itself, from inside they do it, because outside is not suitable of higher level. So we can say this reinforcement shall be done reinforcement, all walls and your balance tank, and shall be inspected by immediate inspected by relevant authority. Then that must further be inspected by engineer, and wall can be closed after approval of steel reinforcement. At this time, question of joints won't be important, but when we make inspection before pouring, that will be important, because you have to take vertical water bars embedded half here and half there on your wall joint, construction joint. Applies to everyone. Wall is very important item. You know it. Wall shall tell what status people are. Can they do it correctly or not? Moreover, this is varying depth wall. One depth on shallow end, one depth on deep end, and also trapezoidal elevation on in between walls. You have to do it using stages. You can do deep wall first, and also you can do shallow wall first, depends on, and then one time now you have to start, you can say, balanced tank wall and deep end wall together. You have to, setting is already there, internal and external setting are there, kicker is there, and you can put your sheets in position. Now you have to do base wall, that is wall perpendicular to each other, that is deep end wall and one of side walls, balanced tank. Both you have to take together. You have to make sure in this portion everything is okay. You have to provide external sides before concrete steel is inspected, and that takes control over it. And we have to provide deep stand beam on whole steel net parts. You have to inspect steel, clear it, You have to see if some electrical services are fixable, you fix them. And then close walls. Close walls, put shutters, put supports, tie bolts where required, and one side supports. If you can put outside also, it's okay, fine, and there's no harm in that. Then you have to control your plumb check and line check, and that gives that you are fine, you are given approval for concrete. Checking takes time because you have to check plumb, you have to check orientation, and previous line also. And that's where we understand about our structural work. And then pouring of course is required, which, as you can say, quantity you can calculate. You can also prepare another wall. Of course you need material for that. Say you prepare this wall, this wall, and you have to prepare this wall. Two wall you can prepare same way. It's easy on this 1 meter deep only, so you can do that also simultaneously. And you can engage, you can erect temporarily working scaffolding for these two areas. And then you can have inspection, closure of formwork, erection of supports, alignment, etc. And you can go for working platform. After all this, safe working platform, and engage 5 or 6 people. So my dear friends, your two walls can be poured. One wall shall be poured in 3 layers, that is shallow end wall, whereas deep end wall shall be, yours says about 2.5 meter, shall probably be poured in 4 layers or 5 layers, I think 6 layers, probably 6 layers, and also this will continue with trapezoidal portion. So 6 layers in this case and 4 layers in that case. Means you have taken this portion, or probably this portion 1, or you can take this portion, depends on how you do it. Where you have to provide construction joints, you have to take care accordingly. You have to do it. There's no way out. And you have to repeat that for all other walls. That is purpose of walls. And when you receive concrete from batching plant, you have to check document issued by batching plant so that time difference is made sure within limits. You have to take by wheelbarrows on concrete and test slump which are that's purpose of wall. All walls you can do that. Balance wall, balance tank walls you can take up like that and do that. Now your all tank is done. All concrete is all finished except roof slab of balance tank. Those walls you have finished. Curing you have been doing. No need explaining that again and again. And balance tank wall is left. Roof is left, for which you have to work again on scaffolding, suspensions, Balanced tank roof wall is important item. In this case, not a problem because walls are there, so just slab is required, no beams. Could be, depends on design, but I think in this case it's slab enough. Directly can take quite short shutter, level it, provide reinforcement, level it, and before that you put marks on wall. So from there you can take up what height you have to go, and then provide reinforcement, electrical services concepts, and profile of level. It's also a small one, profile of manual covers. If you have manual covers to put directly, or you can, no harm to put directly, or can be installed later. Then you have to pour baffle slab, roof slab according to slab requirements. After that, important points comes in, which is much more important than all this. These, but diving board and ladder, all this is separate item. I'm not going to waste time in that. These will be installed later on. Important point is, after shuttering is removed, formwork is struck from walls as well as from slab. Important point is that what you constructed here, that is water containing, water retaining structure, and it must be watertight. That points can be proved only by one way, and that's proved only by one way, that you have to display or to demonstrate there's no leakage and this is full of water. That point you have to test. That's very lengthy process, lengthy or no lengthy, it is to be done. So you read B8007, that B8007, what it says, and we have to follow that, what it says. B8007, I don't think I have that one. Let me see if I have that. Here this, yes, let me see another one. Let me see in the 0 course. I think I don't have here as well. It's not, I'm unable to find that, unfortunately. Let me go to somewhere else. It's a very important item, is 8.7, but I'm not finding that. BS 2007 Code of Practice for Design of Concrete Structure for Retaining Solutions withdrawn as proceeded, published dated by 92/2006, and that's this one. not finding that information here. Type testing, type testing. Let me I got something here. I'll give that one only for you to get him only. Okay, let me take print out of this. Whatever I can get, I can give you. That's important. Whatever is possible, I can get. So this is concrete tank leak test. When first filled, this is IABS clause 292. This when first filled, liquid level should be maintained by addition of further liquid for stabilizing period while absorption and heterogen. Okay. Upon completion, tank shall be tested to determine water tightness. Tank shall be filled with potable water to maximum level. Test shall consist of measuring liquid level over next 24 hours to determine if change has occurred, if any change has occurred. If change is observed and exceeds maximum allowance, test shall be extended to a total of 5 days. If at end of 5 days average daily change has not exceeded maximum allowance, test shall be considered satisfactory. Liquid volume loss of a period of 24 hours shall not exceed 1/20th of 1%, 1/20th of 1% of tank capacity, that is 0.0005 into tank volume, or if liquid volume loss exceeds this amount, it shall be considered excessive and tank shall be repaired and retested. Damp spot will not be permitted at any location on tank wall. Damp spots are defined spots where moisture can be picked up on a dry hand. All such areas shall be repaired as necessary. Damp spots or standing water on footing may occur upon tank filling and are permissible within allowable volume loss. Measurable flow in this area is not permissible and must be corrected. 10 mm or another specified amount, says concrete tank leaks. This is corrected. Okay. It says a properly constructed concrete tank should exhibit essentially no leakage. If leaks are observed on structure or on ground, they should be investigated and repaired. Go with smallest available amount you can measure. This will depend a bit on geometry of your tank and your measuring equipment. So this is for you, and I just put save in this for so I got it, but I said I think you have understood. I said better it is understand. I again read it for your reference because It's a little easy to remember. It says, let me just do a little bit down. Upon completion, tank shall be tested to determine water tightness. Tank shall be filled with potable water to maximum level. Consists of measuring liquid level over next 24 hours to determine if change has occurred. If change is observed and exceeds maximum allowance, test shall be extended to a total of 5 days. If at end of 5 days average daily change has not exceeded maximum allowance, test shall be considered satisfactory. Liquid volume loss for period of 24 hours shall not exceed 1/20th, that is 0.0005 into tank volume, 0.0005. If loss exceeds this amount, it shall be considered excessive and tank shall be repaired. Damp spots will not be permitted at any location on tank wall. Damp spots are defined as spots where moisture can be picked up on a dry hand. All such areas shall be repaired as necessary. Damp spots or standing water on footing may occur upon tank filling and are permissible within allowable volume loss. Measurable flow in this area is not permissible and must be corrected. A properly constructed concrete tank should exhibit essentially no leakage, and if leaks are observed on structure or on ground, they should be investigated and repaired. Go with the smallest allowable amount you can measure. This will depend a bit on geometry of your tank and measuring equipment. Let's say it sounds okay. We can say. So you have gone through what I said. It's a very important point here. It's a very important point here. I can say. I see. We can go for another example also. Let us see. And it is. Inspection, testing of structures, let's say there is something else. I'm going to just leave it. Alright, so we have gone through this. You have understood now concrete test is very important. Other items shall follow up only after this, so I close this. And this you have seen, you have to construct this all that, you have seen that. Quality criteria applied, this you have seen what I have said, then we are here in quality requirement, which is actually long talk on swimming pool is done. Long talk on swimming pool is done. All time taken today because it's very important item. We'll take up firing range after that. So below ground tank, which gives us, again I repeat, it has elements, components, item number this. It has pool internal size, we have this, and this is shelf, shallow and finish depth. After that we have shelf, deep, and then base, RCC base, walls, bases level wall construction joints, open surface drains shall be a standard drain length and specifically procured for shelf corners and for drain pipes. Shelf submerged pool lights specially required to meet underwater requirements. Internal tiling or shelf horizontal and vertical surfaces specifically required to meet underwater requirements. Lining tile shall also be required. Shelf diving ladder platform, shelf pool carpet around, changing room located around, pergola for relaxation, water chlorination room and service room, and there's explanation for basis lab, RCC valves, balance tank, water tightness testing, and then we have to say that as I said, quality is no joke. It is very difficult to achieve quality in construction. We cannot take it for granted. In construction, quality we have to fight with to achieve quality. It's not easy. Even after fighting, even after encountering everyone, and even if you claim that we are able to get quality, I don't think more than 75% you can get it. It's not possible until people are quality conscious, until engineers are quality conscious, until supervisors are quality conscious, and on top of that, until contractor is quality conscious. That consciousness is not available in general. How much they are strict to quality, it depends upon them. Some people have one understanding of quality, another has another one. There is no uniform understanding of quality, and that's where we fall behind. Now, for example, this water tightness of swimming pool that I talked of, or water tightness of some of the structures, some people don't have any idea about this, and they don't bother. I talk to many people, those are not engineers, builders type. They say, I will do ceramic tiling on that so water won't penetrate it. That is the consideration. Some people don't even use RCC. They don't use RCC sometimes. They don't understand the difference between RCC and block work or brickwork. Depends. I'm not here to criticize people, but representation of facts is also important. Those people who can't represent facts live in different world. I can't say that. Well, my focus is quality, not range of people. This was an important item I considered about swimming pool, and there are chances of leakage. You cannot say there's no leakage at all. Leakage is often. It means maybe we check volumes of that. Even then, some leakages happen. After all, this is concrete, and there may be, despite conducting thorough quality surveillance, quality controls, lapses do happen. It happens. Varying batches of mix of concrete with varying degrees of porosity and permeability in hard concrete. Nothing can be guaranteed. Yes, if we are honest, if we test by honesty, by sincerity, not just to fulfill formality, we should be honest in that. Frankly speaking, if after a few years complaint comes, your tank leaking, this water walls are leaking, what shall you feel at that time? Maybe you're not there, somebody else is there. Ultimately, they will say, oh, that person did this. Of course, that's true, you did it. But you think that's the right way? Is that right way? To be defamed like that? It's better to be tough and true. No formality. That's what is. Well, I'll take quality issues later on. I think we can now have a closer of this talk. It's an important item for me. Swimming pool and all items that we did are important. No item is, you can say, sub-important. After all, it is engineering, it is important. No way, no way out, no way in. We have to do it. That's the important point. If we can't do it, we miss it. It's life. It's engineering. It's model of learning. Thank you very much.